Hello everyone, my name's Debbie Roberts. I'm the co-author of the Mission Science student book, workbook and teacher guide. I was involved in the first edition as a co-author, and for the second edition I did quite a lot of the mapping and the designing of new features with the rest of the team, and so this is a real part of me. I've been a teacher for quite a number of years and I've been involved in education for a long time. I've written a lot of books and this is my second edition for this publication, and it's really good and I really like it. And if I was teaching, I've often said that I would use this resource. It's the kind of thing that I would use in my day-to-day teaching. So I'm one of the authors. I was the author of the first edition and here we are for the second, and it's really exciting, and I'm really excited and proud to be able to talk to you about the second edition of the Mission Science resources. So right from the start we look at the covers. The covers have been updated, they're more engaging, they're designed to inspire students to ask questions, to want to know more. They want to know about the content. What's all this about? That's the idea of it, to draw them in, to act as a stimulus for the content that they will be learning throughout that book. We've also introduced some new features and we've updated others, and we've, got rid of some because we wanted to replace them by some better ones. We wanted to update things. So on the contents pages, we now identify life science, earth and space science and physical science. These are using really user-friendly icons, and this all aligns with the OACS standards, which is really important that we have that continuity. The opener pages have been kept because we felt really strongly about this, because they have been designed to stimulate and enthuse learners. And inquiry-based learning, at the heart of it, is asking questions, and the powerful questions come from the learners. And so by introducing the content in this way, we'd like to think that it stimulates this questioning. Why? What's that for? Why is that happening? And so we've kept these, but they're now much more engaging, much more up to date, really, really colourful, lots happening with the key features on there. So they also include the features and lots of information, for example the keywords, which are really, really important. So these can be used in lots of different ways, and they're explored in the teacher guide. So there are lots of different ways to actually use the keywords. It's really important that we don't introduce keywords and give a definition. We want the students to learn what the keyword means and then to define them themselves, and that's when it becomes a key literacy skill. ICT is a focus in these books and it's intertwined throughout the content. So these pages and the content pages throughout the book have talking point features. These are absolutely crucial and the key to our inquiry-based approach. They encourage pupils to discuss, share ideas and knowledge, and this can be in pairs, as small groups, or even as a whole class. It can start as a pair, it can expand into sharing ideas with other pairs and become a group and then a whole class. There are so many different ideas and different ways to use these, but they are actually important and they're very, very, very key to our approach in these books. We've also continued to include fascinating facts, but we have updated some and we've changed some around somewhat. These are also included to stimulate, to trigger that questioning, to trigger that inquisitiveness and that engagement. We want students to discuss things. They're not assessment questions, they are discussion questions. We want the students to start talking about the content and questioning what's before them. We also wanted to promote the work of scientists. We wanted to promote the work of the scientific method and what science really is, and the real world feature does that for us. It allows us an opportunity to look at what other scientists are doing and the scientific approach and method and what scientists have actually achieved. It highlights the importance of real world science and the use of science in everyday real world activities. The inquiry-based learning approach has been retained in the second edition. So there are many activities, investigations and research opportunities, real hands-on learning opportunities that support the learning of the content and the key skills, which might include communication, problem solving, collaboration, research. The investigations are clearly identifiable because they're actually on like graph paper. They've got a graph paper background, which automatically lead the students and teachers to know that this is some kind of an investigation. This is an experiment. This is something that we're going to inquire about, and we're going to find out answers whilst working on those key scientific inquiry skills. So students will be encouraged to make predictions, to predict for themselves, to plan investigations that will work to find out if their predictions are correct or not. They'll be encouraged to record and observe their own observations in investigations and those of others. And then finally, from an early age, they will be evaluating and they will be looking at their evidence and the data and evaluating if their experiments and the setup is actually being accurate. Do they need to change anything? They'll also be reporting back to key groups, to other groups, to their class, reporting in different ways. Will it be a verbal discussion? Will they present their ideas in that way, or will it be a graph or a chart? The research feature's also been improved. We wanted to ensure that students solve problems and find the answers for themselves. We wanted to encourage this questioning and the resolving and the finding of answers to questions and solutions to problems through really key and effective research, because this is a skill that they carry forward and they'll use for the rest of their lives, not just while they're in a science lesson. At the end of each section, there is a test yourself still. And this feature really is about students reviewing their knowledge. What have they learned? What do they recall? What are they not so confident about? What do they maybe need to look back on and review what they've done in that unit? And it's also an opportunity for the teacher to evaluate what the students actually know. Do we need to go back? Do we need to reteach a section? So it actually is really key in informing future planning as well. So in addition to the features already discussed, there's also the challenge symbol, which we used before. And this identifies opportunities for students and learners to extend the knowledge further. The safety feature explains how students can work safely in lessons, particularly investigations. This is really crucial in an inquiry-based approach because students will be encouraged to carry out hands-on activities and tasks and investigations. And so safety is important, and it's important that students from a very young age become familiar with safety rules and regulations, and to recognise how to keep themselves safe and everyone else, including staff. At the end of each unit, there are science projects. Now, these are ideal for blended learning. There are so many different types of blended learning that are actually used in these projects. They're not designed just to be used in blended opportunities, but they do lend themselves to it beautifully. They provide students with opportunities to be creative, imaginative, things that they don't usually associate with science necessarily. So they're using the content, they're using what they've learned, the objectives and the outcomes from the units, but then they're using them in a slightly different way. There are also questions and there are tasks in the Check Your Learning section. So this is an opportunity to review the whole unit for students to really reflect on the learning throughout the unit, and again also to inform future planning. No point moving on until we're sure that we've fully understood the content so far. I really like the scope and sequence feature at the start. I think this is a really useful tool for teachers, and we were very keen to keep this in the second edition because we get such good feedback about it. So teachers and students can easily see what they've learned and what they'll be learning next, which is key. It's really important as educators and students that we know what we need to understand for the next stage in our education. And so that tool at the beginning is fantastic. It can be used as a mapping tool to organise the structure of long-term learning, or just to look at what's coming next, what's coming before. Throughout the student book, there are key links to the workbook, the pages that are specific for that page in the student book, the pages in the workbook that will encourage or support students. The workbook should be used alongside the student books as an additional and supportive tool. The workbooks can be used in school, independently, or they can be used outside school, at home, independently as well. So it's about not only working as groups and teams, but some of the pages are directly aligned for independent learning. These are key tools and skills that students need to learn and practice from an early age. So each unit begins with an opener page in the workbook where keywords are discussed, and activities support students in the learning and defining of these keywords. The idea is that the pages stimulate and engage students again and encourage them to find out more about the content. The workbook pages are write-on, which means that students can record their own answers. They can answer the questions themselves. They record their results and observations during and from investigations. So again, this is encouraging inquiry-based tasks, the recording of results, the accuracy and the importance of it. There are features in the workbooks that are identified using really clear and user-friendly symbols, which are used consistently across the whole resources so that students can be confident in their understanding of what these symbols actually mean. There are some home learning features, and the home learning feature identifies tasks and activities that could be completed at home. They don't have to be, but they could be. Often parental support is required to complete the tasks, but the equipment and the resources are usually very easily found at home. We're really proud to develop investigations and activities that are based around kitchen science, really. The things that would be readily available at home. You don't necessarily have to go and buy anything or resource anything. We base them around things that we feel should be readily available. So it's not a major task to actually carry them out at home. This home learning does develop literacy skills, and it also continues the learning from inside the classroom to outside the classroom. So these tasks encourage students to discuss the learning as well with the people at home, which is fantastic that parents and people at home can actually be engaged in their own students' learning. They have a really deep understanding of what they're doing in school and how they're understanding it and how they're learning it, because they can share their ideas. They're encouraged to share what they've learned. This also encourages students to work independently, and it also encourages other key tasks and skills, including taking responsibility for their own learning and also managing their own time effectively. If they know they need to hand this worksheet in on Tuesday, then they need to manage the time accordingly. Again, there are many opportunities for blended learning in these books. So many different types are encouraged through learning in classroom, learning at home, research, the investigations, fantastic opportunities for blended learning. Safety warnings are also a feature, and these support students in working safely during the learning and engagement in activities and investigations. There's also a remember feature, which provides helpful hints and tips and reminders of what students might have learned earlier, or it reminds them to look back in the student book, what they actually covered in the student book. The challenge feature is also in the workbook, and this is used consistently through all the books so that they can be used comfortably throughout the primary learning experience using mission science. The pages once they're completed in the workbook, can actually also be used to review learning during and at the end of the unit. So students should be encouraged to look back what they actually completed, what they didn't complete, which things do they need to learn more about, what did they feel really confident about. They can also be used for differentiation because a lot of the pages are supportive activities to support some students in their activities that are carried out in the student book, the investigations, some of the activities that might need a little bit of support. They might be written in a longer format so there's more information, for example. There's also a challenge which extends and challenges students' understanding. So it's really a good resource for differentiation for your class as well. This differentiation is often through different kinds of tasks, but it also can support students to synthesize the ideas and understanding that they've gained in the student book into new situations, things that they've not necessarily studied or linked to. And the keywords and terms are also discussed further. The Teacher Guide is a great resource for teachers. I'm really proud that they support teachers in the delivery of these activities in and outside school. There are many alternative suggestions for different materials to use or a slightly different activity. Maybe you haven't got an outside area, so we might have been able to use some kind of microscale teaching so that students don't miss out on anything. So it could also, and does occasionally, identify misconceptions that we have felt could be developed in certain areas throughout the units. And they also identify areas where deeper knowledge might be required. So we might support teachers in giving them the next stage so that they can actually deliver at this stage because they know what happens or is coming next. I'm personally very, very proud of these books. It is something that I've put a lot into. I have a great deal of ownership of them. I'm very, very proud of them, and I'm proud of the early feedback that we've received. They're now in line with OECS standards, but more importantly, I think they're really exciting and interesting and engaging. They inspire students to want to learn and to become scientists. The students are treated like scientists, which of course they are because they're studying science through a lot of the features, the investigations and the activities. I really hope you enjoy these books as much as I've enjoyed writing them. I am genuinely very, very proud of them, and I really do wish I'd have had a resource like this when I was in the classroom. So thank you for listening, and I hope that has been helpful. Thank you.